Tree diagram worked example. Assume that the cloud cover on any day can either be sunny with a probability of 0.8 or overcast with a probability of 0.2. Given that it was sunny, the probability that it will rain is 0.3. Given that it was overcast, the probability that it will rain that day is 0.75. How would this look on a tree diagram? So firstly, let's start off with the notations that we're going to make use of. And the first one that we're going to do is we'll let S be sunny. So S is the symbol that we're going to use to represent a sunny day. And for the sake of convenience, to make things easier for us, what we will then do is we'll let NS be not sunny. And what not sunny refers to is that it's an overcast day, that we have cloud cover over. So these will be the first branches in our tree diagram. The first one is S for a sunny day, and then the second one is NS for a not sunny day or an overcast day. We're told that the cloud cover is sunny with a probability of 0.8. So this is what we write over here. And then we're told that the probability that it will be overcast is 0.2. And they could have left out this information over here because we know that the probabilities, this vertical addition in a single split always has to add up to 1. And we can see that this is indeed the case as we have 0.8 plus 0.2 adding up to a total of 1. So now that we have our sunny and our not sunny days, let's go look at the weather forecast for the rain, given that it was either one of these days. So we're told that given that it was sunny, the probability that it will rain is 0.3. So then we'll use the notation that we let R be rain. And then for the sake of convenience, we just let NR be not raining. And this is one of the ways in which you can label your diagram. So as long as you have some descriptions for how you're labeling your tree diagram, there should not be any issues with it, as long as you stick to them. So R represents a rainy day, and NR means that it will be we won't have any rain that day. So we're told that given that it was sunny, the probability that it will rain is 0.3. So rain, given that it is sunny, is 0.3. This is this branch over here. So this is the probability that we have rain, given that it was sunny. And this over here is the probability that it was sunny. So this is how the branches look. You have the first branch being the probability of that event, and then the second branch as we move along, this is the probability that we have rain, given that we had a sunny day. So again, as I said in the first part of this video, I said that the vertical addition of any one branching segment should total up to 1. So if we have 0.3, that means that we must have 0.7 over here for not rainy, given that it was sunny. So that means we have 0.3 plus 0.7, that totals up to 1. So this is the probability that it is not raining, given that it was a sunny day. So we've sorted out this branch, the branch originating from a sunny day. Now let's look at a not sunny day. What we're told over here is that given that it was overcast, which means NS, a not sunny day, the probability that it will rain is 0.75. So that means the probability of R of a rainy day, given that it was not sunny, is equal to 0.75. And this is this branch over here, 0.75. Then we have not rainy. So not rainy, if this is 0.75, as I've said, the total of these branches originating from 1 point has to be 1. So 0.75 plus 0.25 totals up to 1. So this is the probability that we have no rain, given that it was not sunny. So it's equal to the probability of us having no rain, given it was an overcast day. So this is how we would represent this information in a tree diagram.